Hello everyone, welcome to Pepcoding. So in this video, we are going to discuss the question from binary tree, that is all nodes distance k in a binary tree. So what will be given? We'll given the root of a binary tree and the value of a target node, target and an integer k. And you have to return an array of the values of all the nodes that have a distance k from the target node. So we'll be discussing all these 3 points directly in our binary tree. So let's move to our binary tree. So this is our binary tree, and what information will be given? We'll be given a root value and we'll given a target node value and an integer k. So we'll be given a target node value and an integer k. So root will be, suppose for this particular binary tree, root will be 12, and let us consider this as our target, that is 8, and 3 as our k value. Okay, so what will be done over here? See, we will be printing all the nodes which are at distance 3 from 8. See, like this question, we have one more question in level 1 in binary tree section, which is print all the nodes at distance k. So this is similar to that question. In that question, we have an approach where we need to find the node to root path, and in that procedure we were using a lot of space. So this is also the same question, but in this we will use an approach which will consume less space, and apart from recursive space we'll be using less space in comparison to that question. So let us discuss the more optimized solution. So this will be in that question in level 1. What we were doing, we were finding the node to root path. Suppose 8 was our target node, so we were finding node to root path which was containing 8, 1, 3, 5 and 12. And if the value of k was 3, then for 3 we were for value of k as 3 we were printing k levels down. For 8 it was 3 levels down, for 1 it was 2 levels down, for 3 it was 1 level down, and for 5 it was 0 levels down, and for this it will be -1, which will do nothing. So we'll discard this case. See, this I am discussing the approach of that question which is in level 1. Here we'll discuss another approach which will be more optimized. So here for 8, 3 levels down is nothing. For 1, 2 levels down is 15, 6 and 4. So 15, 6, 4 and 15. But we'll discard 6 and 4. Why? Because it is basically 2 levels down from 8, 2 levels down from 1, but not 3 distance away from 8. So we'll discard this 6, 4. How we'll discard this? We'll block this direction. How will we block? We'll block 8 for 1. And for 3 also, when we'll be printing 1 level down, so for 1 level down this will be considering 1, which is incorrect because 1 is not 3 distance away from 8. So we'll discard this direction. So how we'll pass this node as blocker node for 3? 1 will be blocker node for 3. So our answer will contain 2. And from 5 our answer will contain 7. So basically our answer will be containing 5, 15, 2 and 7. So this is the approach we have learned in our level 1. So now what we'll be doing, we'll be implementing this approach. We'll be implementing more optimized approach. In place of this node to root path, we'll be doing something else. Okay, so I hope till now you have understood the question. What our question is trying to say, that from 8, 1 distance away is 1, 2 distance away is 3, 3 distance away is 2. Also in this direction, 1 distance away is this, and 2 distance away is this, and 3 distance away is this. So answer will contain this. From here, 2 distance away from 8 is this, and 3 distance away from 8 is 5. So our answer will contain 15, 2 and 5. So this will be sorry, this is 0 levels down from 5, so this will be 5 itself. So our answer will be containing 12, 2, 15, 2 and 7. Okay, so till now the question is clear. So we'll be implementing this thing in our code. So let's move to our code section. So this is our function distance k, a route is passed, target is given and k is given. So our very first step is we'll create a vector answer, and in this vector we will be storing our answer. And now I am calling a function distance k, which will contain root value, target and k and answer, and from here we will return our answer. So distance k, this will contain root node, target, int k and answer vector of integer. Right. And we'll require one more function, which will be k levels down, that is k down. We'll pass a root value of k and a null node. Okay, that is block node, sorry, not null node, that will be block node. This will be containing our answer. We'll maintain our answer in this vector. So what this function will basically do, we'll make the base condition. Suppose root equals to null or k is less than 0 or root equals to block. In all these conditions, we'll simply return. And if k equals to 0, then it means this is the node which we have to include in our answer. So we will push that value in our answer. So for this one, k value is 2. For this one, k value is 2 and blocker node is 8. Blocker node is 8. So this path is blocked. So what we have to do? We have to print the nodes which is 2 levels down. 2 levels down from 1, and also the condition is 8 is blocked. So for this we will be firstly checking the condition, root equals to null, no, k is less than 0, no. So root equals to block, no. So we'll be not entering into this condition. If k equals to 0, no. So we'll make call to left. So here root will be 8 and this will be k minus 1, which will be 2 minus 1, that is 1, and block is 8. So then here we'll check first condition, and in this condition, if any of the condition is true, then this whole condition will become true. So here root equals to block. This is root and this is block, which are equal. So we will return from here. So we will not go into this path. Then what will happen? Then we will call to right. Left call is finished. Now we'll call to right. Here also root dot right. This will be 11. This will be 1. This will be 8. So here root equals to null. No. K is less than 0. No. Root equals to block. No. So we'll check this condition. If k equals to 0. No. K is not equals to 0. Then again we'll make for left call. For left this is null. So root is null. So we will return from here. Now we'll call for right. For right, this is 15. K is 0. Blocker is 8 again. And then we'll check first condition, root equals to null. K is less than 0 or root equals to block. So this condition is false. Then we'll check second condition if k equals to 0. Yes, k equals to 0. Then we'll push this answer. Push this value, root dot value in our answer. So from here, our answer will be containing 15 and then we'll return from here. So we'll be returning from all left and right is completed, return, left and right is completed, return. So this one will return answer as 15. Okay. So actually this will not return nothing because this is a void function. Instead of returning, what is happening? Our answer will be containing 15. Okay. So this is how this function will work. Now we have discussed the function. Now our next thing is to create another function, which was finding distance. Okay. So what we'll be doing in this function? Over here is k. So this is base condition. If root equals to null ptr, then return -1. Second condition, if value of root equals to target, then call the function k levels down, and for k down, and for k down, value of k will remain k, comma k. For this blocker will be nothing, so null ptr. Also return 1. Now our second thing is to calculate left distance. Okay. Pass root dot left, comma target, value of k and answer. We'll put the condition if left distance not equals to -1, then call the function k down, root, comma k value will become k minus left distance, comma root, left of root, comma answer, and return LT plus 1. See, if you are not getting this thing, what we are doing in this function, then no need to worry. For not just understand the thing that this is the alternative way, or this is the optimized way, which is the alternative solution for finding node to root path. Basically, in level 1 question, we were finding node to root path for implementing this thing, which was consuming a lot of space. So for not just understand this thing, when we'll do the dry run, then you will understand this thing more clearly. So this will be right. This will be also right. This will be RD plus 1, and we'll return -1 from here. So now let's do the dry run for this to understand more clearly. I hope it will be visible. So start from here. This is the first condition, this is second one, this is the third part and fourth part. Okay, so initially root value is 12, k target is 8, k value is 3. So we'll pass this thing 12, 8, 3, and first condition will be checked. This is false. Second will be checked. This is also false. Third will be call to left. Okay, so LD will call again this thing. Again it will be 5, 8, 3, and first condition will get checked, second and third. So for third again left call, then this will contain 7, root will contain 7 because we are calling root dot left of root, and target will remain 8 and k value is again 3. So now again we'll call for left. First, second, third will first statement executed, second statement executed, third statement executed, call for left. So this will be containing null. So here root is equals to null. So if root equals to null, so return -1 from here. Then this -1 will get attached to what? This -1 will get returned -1 will get attached to LD, that is equals to -1. Again for 4, right will be called. This will contain null, so we'll return -1 from here also. So from here RD will be containing -1. So conclusion is this: from here LD and RD is containing -1. So let me write clearly. From here LD is equals to -1 and RD equals to -1, and all left and right are completed, so we'll return -1 from here. Okay, we'll return -1 from here, so this -1 will get attached to LD. Now again fourth call for right distance. For right distance this will be 3, 8, 3. Again first condition will get checked, second will get checked, third, for third left call. Okay, here it will be 2, 8, 3. First condition is false, second is false. Jump to third, null will be, root will become null, so it will return -1, which will get attached to LD. Okay, so from here -1 will be returned and LD will be containing -1, RD will be containing -1. Overall left and right call are over, so this will return -1. Okay, so from here -1 will get returned, which will get attached to LD. Then call for right. Calling for right, this will be 1, 8 and 3. First condition will be checked, second will be checked, false. Now third for left distance. Now this will be 8, 8, 3. So first statement will get checked, root equals to null, false. Second will get checked, so for second root dot value equals to target. This is root dot value and this is target. This was root and this was target. This was value of k. So root dot value equals to target. So we are trapped in this second condition. So what this will do? This will call k down function. So k down function, root will be passed. We have discussed the k down function previously in this video only. So k value is 3 from here. Blocker node is nothing. So from 8, 3 levels down is nothing. So our answer will be containing nothing. So this function will return nothing. Now we will return from this. And what this will return? This will return 1. Where this 1 will get attached? This 1 will get attached to LD. So LD will be containing 1. Okay. Now LD is not equals to okay, so this has from here it has returned 1. So this has returned 1 and this 1 will get attached to LD because we have called 1, 2 and 3. Okay, so LD is containing 1. So 1 is not equals to minus 1. Then what will be called? K down function will be called. So this will be K down function and root is 1 and value of K is K minus LD. So here K is 3. 3 minus LD, LD is 1, 3 minus 1 is 2 and root dot left. Blocker node is root dot left. So blocker node is 8. Okay. So from here, we'll call K down function for printing 2 levels down where 8 is blocked. So this path is blocked. 2 levels down from 1 is 15. So this will return me 15 and our answer will be containing 15. Till now our answer is containing 15 only. And then after calling this, what will be returned? Return LD plus 1. What is LD? LD is 1. So LD plus 1, 1 plus 1 is 2. This will return 2 and this 2 will get attached to RD. This 2 will get attached to RD. Now RD not equals to minus 1. So RD is not equals to minus 1. We are at this position over here. So let me erase all these things. So till now LD equals to 1, RD equals to 2 and we are checking this fourth condition. So 1, 2, 3, 4. Okay. So we'll call K down function where root is 3 and K is K minus RD, that is 3 minus RD, 3 minus 2, that is 1 and blocker node is root dot right, right of root, that is 1. 1 node is blocked and we'll call this function. This will give me 2 because 1 levels down from 3 is 2 and 1 where 1 is blocked. So this will give me 2. Okay, and we'll return RD plus 1, that is 2 plus 1, that is 3. We'll return 3 from here and this 3 will get attached to RD. Okay, so we'll return 3 from here. Now again, what will happen? All left and right are over. So if all left and right are over, so this is 3. Okay, so still right is not over. We have returned RD plus 1 from here, but this RD has received 3 and now it's turn for checking this if condition. So RD not equals to minus 1, 3 not equals to minus 1. So we'll call K down function. This time K down will contain root value as 5 and value of K is 3 over here and RD is also 3. So 3 minus 3 0 and blocker node is root dot right, that is 3. Okay, and we'll call K down function. So 0 level down from 5. So that will contain 5 basically. So from here our answer will be containing 5. Okay, from here our answer will be containing 5. So this is 5 basically. This is right. 1 distance away, 2 distance away, 3 distance away. Okay, so now what will happen? This RD is this we have received. Now we will return RD plus 1, that is 4. Now this is exceeding the limit. Here it will represent minus 1 indexing. That is why we will terminate from here. So let us run our code. Okay, so there is some mistake in line number 19. Void K down, tree node B was not declared. Okay, so basically in line number 19, this is the mistake. We have written tree. This will be capital. Okay, now let us run it. There is some more mistake. Before token, line number 33. Let us check the line number 33. In target, int K vector. Okay, so this will be vector. Okay, so Now let us run it. This is root, target, key and answer. So return function 61. Okay, so 61, this will be return answer. Still before return expected semicolon, so this will be semicolon. Now let us run it. So this is return answer vector tree node. Okay, so this will be int. Okay, so basically we are returning vector of int, but here it will be also answer will be of vector int. So this will be int I. This will be I. So it is running successfully. So that's the end of our video. I hope you have understood the question and the solution. So we will be meeting in another video with another question. So thank you for watching.